Hello, this is Mr. Benjavani,
And Mr. Geiwitz.
and today we're going to do kind of a unique podcast, one that's going to be used for basically all AMSA science classes. So we may or may not be your current science teacher.
You may never have us.
Maybe.
Hopefully you don't.
If you're lucky, you'll have Mr. Geiwitz, but not me.
So today we're going to talk about dimensional analysis. And dimensional analysis is where we want to convert units, is primarily what we use it for in the sciences.
Yeah. What do we use it for? Converting units.
What else do we use it for? That's about it.
That's about it. Including the metric system. You may learn, all sorts of different little tricks on how to work the metric system, but here at AMSA we want to use dimensional analysis to convert our metric units. We don't want to use the count the knuckle method or the loopy-de-loop thing or whatever you might find.
I've
right?
never even heard of that stuff before.
We want to, we want to use dimensional analysis.
So there's 4 easy steps to this. The first one, you want to identify your given and desired units. You could be given something in, say, meters, but you have to convert that to kilometers. Or it might not necessarily be between metric stuff. You might get something in meters and convert it into feet.
Right. Or in chemistry, a lot of times the units aren't necessarily easily observable as being kind of the same thing. You might convert grams to moles, and moles to numbers of particles.
Yeah, but that's chemistry. That's all witchcraft anyway. All right, second step, you want to identify the conversion factors to use. We'll talk about that when we actually do a problem. It's a little easier to see what we're talking about.
Yeah, when you first start doing this, you might want to actually write down the conversion factor. And then when you get good at it, you don't really need to write it down as much.
A good place to find conversion factors would be in the front or back of your book. Usually every science textbook is going to have conversion stuff, either in the front, back, both, or in some appendix in the back sometimes. But usually it's right in the front or back of the book.
That's right. All right, so here's where the meat is. You're going to set up an equation that's you're gonna actually write this thing down. You're gonna write down the given quantity with its units, and then you're gonna multiply that by one or more conversion factors until you get to the desired units, and then you're actually gonna do the arithmetic with the answer on.
Plug it in your calculator and figure out what it is.
All right. So, Mr. Geiwitz, how about you work out an example for us?
So we'll do a really easy one to start out with. Let's say we wanted to convert 15.7 centimeters. We want to change that into inches.
And so I think that this is our given. And inches would be our desired. So I've identified the given and desired.
Exactly. So we're given 15.7 centimeters. We want it in some number of inches, some question of inches. That's supposed to be a question mark. So
I can see that. I can see that. That works.
The next step would be to identify a conversion factor. And I know in the front or back of physics book, one of the two, it gives you a conversion factor of 1 inch equals 2.54 centimeters. So how we make this into a conversion factor, there's 2 different ways. Since we know 1 inch equals 2.54 centimeters, we're going to write this as a fraction. So 1 inch over 2.54 centimeters. Or you can also write it as 2.54 centimeters over 1 inch.
How do I choose which one? If you can do it, can I just pick either one and it always works? Or
no, you're going to have to, when you're doing this, you're going to have to pick the one. We want to convert the centimeters into inches. So whenever we multiply our original given by one of these conversion factors, we want these centimeters to go away. And the only way that's going to happen is if the centimeters are on the bottom of the conversion factor fraction.
Oh, you want to cancel out the given units.
I don't like the word cancel out. They're dividing out.
They're dividing out.
They're dividing out.
Okay, that's fine. We can
But yes,
go with
cancel
that.
out, divide out, same difference.
And divide out the given units, and we're going to have the desired units that
You're left with your
we left
inches. And the reason why we can multiply by these conversion factors is because if 1 inch equals 2.54 centimeters, then 1 inch divided by 2.54 centimeters is technically 1. Or 2.54 centimeters divided by 1 inch is also equal to 1. So we're keeping all of our math straight. It's totally legal to multiply any number by 1. You can multiply a million by 1, any number you want by 1, and you're still going to end up with the same answer. But it's just going to look different now because we're going to have different units, and we're going to have a different magnitude out in front of it too. So to actually do this problem, you're going to take your 15.7 centimeters, and we're going to use this conversion factor right here because the centimeters are on the bottom. It's going to cancel out these centimeters.
It's going to divide out those centimeters.
Exactly, that's what I said. So 1 inch over 2.54 centimeters. So when you're multiplying these two together, these centimeters divide out, and you're left with your inches, which is what we want. And if you actually plug this into your calculator, you get something that looks like, where did I put it? 6.18 inches. So now we have successfully converted 15.7 centimeters into inches. If you don't believe me, grab a ruler and check.
Amazon,
I don't.
go away.
Buy Amazon.
Oh, that's hilarious.
Give us 1 second. There's always crap like this that goes on. There we go.
Okay. All right. In all seriousness, guys, this is what you need to write down. It needs to, oh my goodness, go back.
All right, you gotta click on the little pen thing here.
Oh yeah, because Amazon came up. Screw me. You've got to write that down. You've got to write the given. Let me change the color a little bit. You've got to write the given. You've got to write the conversion factor, and you've got to write the answer, and the answer has to have units on it.
And it's also really helpful while you're doing this, because sometimes you might have more than one step. You want to make sure you're crossing out these units as we're getting rid of them. And when you get to the unit that you're looking for, your target unit, your desired unit, you want to circle that guy, put a little check mark on to know you're done converting that unit.
It really should always look exactly the same. If yours don't look like ours, maybe minus a little bit of the scribbly mess here, then you're not doing it right. You've got to show the work.
Which means you're doing it wrong. Right. So I want to show them one thing real quick. So if I would have chose the wrong conversion factor, let's say I would have multiplied it by 1 inch on the bottom,
right,
and the 2.54 centimeters on top, my centimeters aren't going to divide out here. Instead, I'm going to be left with units that look like centimeters times centimeters over inches.
Centimeters squared per inch?
Yes, centimeters squared per inch.
That's my favorite.
Which makes no sense in any science, except for maybe bio. They might figure something to use for that.
Nice. Oh, I went the wrong way. I want to go forwards. There we go.
So now we're going to do a multi-step problem. You're going to see this a lot in physics because a lot of your units will be something over something. Like, for example, if I give you 25 meters per second, and I want you to convert that into miles per hour. Like, that's a little trickier than doing a straight, centimeters to inches conversion. So let's say I want to convert this into miles per hour.
All right, so you read the problem, you identify the given quantity as being 25 meters per second and the desired being miles per hour.
Yeah.
All right.
Here's my given. Here's my desired. And what's the next step we have to do?
We have to identify some conversion factors.
Identify some conversion factors. Now, there are probably a little more shortcuts in your book, but I want to make this a multi-step problem, so I'm going to give you these conversion factors. I'm going to give you that 1 meter equals 3.28 feet. I'm going to give you 5,280 feet equals 1 mile. I'm going to give you 60 seconds in 1 minute and 60 minutes is 1 hour.
You might not find those in the book, but I think being...
Yeah, a lot of times they won't give you the time conversions because we've all grown up
Yeah.
knowing that there's 60 seconds in a minute,
Yeah.
60 minutes in an hour. And after you do a couple of these problems, especially in physics, you're going to realize that there's 3,600 seconds in every hour because we do this conversion so much, you're just going to skip
And
that
6
step.
times 6 is 36.
Yeah, pretty much.
All right. What do you want to give me a chance? Can I try this
Yep,
one, Mr.
I'll let
Gowitz?
you go for that
All right, let's see. I'm gonna do this one in blue, dark blue. There we go. All right. So my given was 25 meters per 1 second. How's that? If I have like a complicated unit, can I do that?
Yeah, that's why I chose this kind of problem, because I wanted to show you that 25 meters per second is the same thing as 25 meters over 1 second.
Okay. So we got meters on the bottom. I want to cancel out, and I'm going to go to feet. And notice the order in which I write this down. I write the units down first. I'm going to start with this conversion factor. 1 meter is 3.28 feet. Okay.
It's also a good thing to only convert 1 unit at a time. Like, you don't want to convert this into feet and then you want to convert your seconds into minutes. You want to keep working with those feet until you get your desired length unit, which is going to be miles.
Right. So if we just take a look at what I've got canceled out, what I can cancel out here is we've got our meters go away, they divide out, and the feet divide out, and I'm left with miles. That's good. That's what I want. Miles. M-I. Miles. And now I'm going to work on the time part, right? And since seconds are on the bottom over here, I want to put the seconds on the top over here. And I'm going to go to minutes. There are 60 seconds in a minute, and I want to get rid of minutes, and I want hours on the bottom. There are 60 minutes in 1 hour. So my final answer after I cross these units out will be in miles per hour. And I get out my handy dandy calculator. I multiply 25 by 3.28. I divide it by 5,280 and multiply by 60 and multiply by 60, and I get...
My calculator's being slow.
Oh, I got Geiwitz.
I'm sorry.
Come on.
Almost there. 5,280 times 60 times 60. Yeah, 55.9.
Around 55.9 miles per hour. There we go. That's how you do dimensional analysis multi-step. This is a very useful tool for converting all kinds of different things. There's practical uses, even just in things like construction. You know, you got to figure out how much tile you need to buy to do your house. You make the measurements, and do some dimensional analysis. And
yeah, we
then
did
you're
my
not
floor
wasting
this
money.
summer, and
Right.
it's the same exact thing. Like, I used my dimensional analysis to figure out how many boxes of tile I needed.
You stand in the middle of Home Depot, and you're working this out, and people say, "How do you do that so fast?" Well, I'm a chemistry teacher. This is what we do, right? All right. So, and I think that's it.
We're done.
Dimensional analysis. There you go. Learn it. It is probably the most important skill to learn early in your career that's going to carry over year after year.
Yeah, because you can use this in any science, math, life.
Awesome. See you guys in class.